Okay, hi. Welcome to another installment of Oracle DBA Tutor. Last time I left off, I was actually going over basically have how you can have that raw data access by basically just having the index query that raw data for you, or you can just store that raw data inside of a index organized table. And then basically what you're doing is you're just using up more of your memory space for you to have this for you to be able to use this feature. And again, in terms of the operations that you would in terms of the approach that you should have in terms of for your operations. So just think of it. The example that I gave you last time was basically just remember that if you have an index reading the table block, you don't want to go over all these blocks. It's gonna if you do the if you do there's a calculation that you have to do to be able to get a sense of which one is more efficient, right? So reading all the blocks is definitely not efficient. Basically just reading one block and going over all the rows is more efficient than basically than reading just a short number of rows over multiple blocks. I mean, it sounds like this would be the first one would be a better approach, but there's a mathematical equation to sort this out, and basically it's the results for typically is that basically it's better to just perform a to read as many rows as possible inside of a block for you to be able to basically just make your to basically just have the index sort of come up with with some sort of representing data for for the so that, for the statistics which ultimately the optimizer will end up using. So again, those are two approaches, but the recommended one is to just read more rows and less blocks as opposed to more blocks and less rows. So just keep that in mind for future references. So now I'm actually gonna just focus on what's called the index clustering factor. Again, so now I'm gonna focus more on just clustering. So and again, so remember I gave you last time the example of the cluster where you have a rack alignment as opposed to the cluster where you have which is more granular. What happens at the object level, the table object, the row data level. So basically, what happens is that inside of the Oracle software, right? So you when you have an index, basically, and you're dealing with a cluster, right? What happens is that there's this thing called the clustering factor, and what it does is it has all the information, right? But it has information on basically if you have a cluster, or if you have a cluster, it's gonna have that information. It's gonna pass that information over to the optimizer. So basically, what you can do with this clustering factor and dealing with your index is you can actually assign a value to that clustering factor. So basically, it's just gonna what it does is it just makes the optimizer it clarifies a whole lot for the optimizer. That's number one. But also, what it does is it's very simple. It has certain standards that for example, if you look at the value for the clustering factor value, right? If it finds that that basically if you have again these are just the two abiding principles that it goes by. So if you have a low number of blocks, yeah, if you have a low number of blocks inside the index, again, so what I'm doing now is I just gave you an example of reading the table object, but now I'm going more into details as into basically how you can actually just tune your index organized table. So if you have a low number of blocks, right, that are covered by your index, what's going to happen is that that's actually going to be considered as a word cluster environment, right? Again, it's going to lead to more efficiency and efficiency in your in the operations, right? But if you have a high number of blocks inside of the index, then basically what that's going to mean is that basically your area is not well clustered. So what it does is the clustering factor is it just looks at how clustered or how scattered your data is inside the index. So let me just make sure I just right. Yeah, so basically, again, so what it does is it's going to review. So what it does is it reviews number one the data inside the index, and number two the data that's in the table object, and it perform a comparison of how of the clustering for those in those two locations. So yeah, and also what it does is it looks at the index rows and figures out if they're accessible or not, and anytime you have a block change inside a block change, basically that value changes. Also, um, so going back to the diagram that I had earlier, so this again, this is especially this is what I'm referring to for in terms of dealing with the blocks, right? So if you have a lot of a large number of blocks, then that means that your environment is not well clustered. But if you have a small number of blocks, then that means that your environment is better clustered, and that's better for faster access, right? So basically, the the clustering factor looks at how the block, how accessible is the block, and also if you have a block change, basically it's just gonna that value is gonna be changed as well. So just again that's again I'm just again this is just to sort of hone in on dealing with indexes, and again this is something again remember this. So the optimizer has two choices, right? One is retrieving data. You can either look at perform a full table scan, or you can perform a an index range scan. So I'm covering the index range scan aspect of the optimizer operation right now. So again, so if you have an index organized table, so basically you have a single environment where everything for the data is being stored. Basically you can make you can have it configured for faster access, or you can not have it configured for faster access by just scattering your data all over the place. And then the single value, the index constant factor is factor is going to be able to basically just deduce how good of a job you're doing in just streamline the activities for the optimizer. So in terms of the clustering factor, so again going back to this ASSM, the automatic segment space management. Once this is if you have this configured in your system, again what the ASSM does is, if you can remember, basically ensure that you have data that's stored, that's scattered in a few number of blocks as possible, and it also regulates who has access to those blocks. So if you have ASSM configured on your system, right, what's going to happen is that this is no longer going to be this is no longer going to apply. The single value that you should whatever that you set it to, and basically and as well as the index of investor, those no longer apply to the to your environment, no matter what the settings are. ASM is going to override this configuration. So if you have ASM, if you have partition data object, if you have shrink space, basically also enabled. Again, this is just to claim unused disk space. If you have free lists being used inside your environment, those are all going to nullify the configuration for your single value and this concussion factor. So again, this concept as well as this concept apply to basically just storage of data inside the index, especially with inside of the index organized table. So and also yeah, this is it. And also in terms of what the optimizer is aware of, so basically optimizer is not aware of what your makeup is for the cluster, right? So again, just going back to what I said earlier, if you have a join operation, if you have a subquery operation, the optimizer is not aware of what those results the SS are. It only looks like the statistics. So how basically just how well you how good of a job you do at just laying out your statistics for the optimizer to review them. then basically the faster the operations will go. So again, I showed you earlier just an example of how you can look at the estimated number of rows in a joint operation, and how the optimizer would have a you have common values for estimated and as well as for actual. And then if estimated is actually lower than actual, then the optimizer would basically just go in with a so like, and we would be sort of would be unprepared for what's expected, the workload that's expected of it. So you just want to be mindful of those two sort of those two values again. So I think I should have that open here. So yeah, this is what I meant. So basically, typically you have you have this basically just estimated rows and the actual rows. So if the optimizer does not have the right insight into for its estimate, then basically it's gonna lead to basically just it's gonna eat up a whole lot more resources, because it has to. So basically, okay, so there's no way to get around this this actual number of rows, right? It has to review. It needs to have a an overall a 50,000, like it look from above into into what what I'm trying to say. Okay, so it needs to know exactly what's being stored, and basically if the okay, so if the optimizer comes in with a 20, with an estimated 20 number of rows, and this is actually was 162. So the statistics for the activities that will be performed at the 120 obviously will be different for the statistics that at 162 obviously going to be different from the statistics on the amount of activity that's expected at the 20 with 20 rows. So again, just be mindful of this, that you want to be able to just have the optimizer just review all of the rows, not all the rows, but review statistics that are very representative of the overall number of rows that are part of your operation. If you have a joint operation, if you have a software operation, so just again, just adjust this right. I'm gonna have a the scripts to basically to just adjust this column value for you to better reflect the number of rows. So just look for that in the discussion section for my OKDB to your channel. Okay, and again, so in terms of the type of joins that are performed inside of Oracle, you have three types of join. You have the nested loop join, you have the and you have the hash join. So basically, the nested loop join, the easiest way to think of it is, so basically you just have, give me 1 second. Okay. So basically you have one table that's depending on the other table, right? So let's say, again, going to the example that I had earlier. So I'm working with, let me do this, minimize this. I'm working with regions and oh man, HR, okay. Select table underscore name from user underscore tables. Okay, so basically, as I've done all along, is I've been working with the countries and the regions table, right? So basically, and then if you can remember, I've already gone over the structure for these two tables. Describe region. Yeah, that's again. Yeah, you have to set the right line size, and I've definitely not done it, and I've also been, this is the same way that I've used from the very beginning of the tutorial. So these settings are all really messed up. And I'm gonna issue the describe countries again. So the reason why I pulled up these two and let me do this. Okay. Um, there you go. The reason why I pulled this, and just for you know for future tutorial sake, I avoid dealing with line size because I have no idea what it does. Again, I just got lucky by picking 10 years, so yeah, I was very lucky. So back to what I was saying. So you have with nested loop, right? You have basically just matching of two tables, right? And you have matching of raw data. But basically, this is very unique because basically with nested loop you only have matching. Um, Basically, you have the matching involves having a dependent. One of the objects being that's part of the operation just being dependent on the other object, right? So basically here, you know, the smaller, I believe the smaller, yeah, actually my, I think the smaller should be the smaller should be dependent on the larger data set. And it can be okay. So I'm just gonna go with that for now. So I think the smaller table is supposed to be is supposed to be dependent on the table that has a larger data set. So the regions table will be dependent on the countries table, and then that's how the matching would occur. And then that's referred to as the nested loop. So if you look at if you ever review your execution plan, if you see a nested loop or if you see a hash join, basically just know that basically that one of the tables was, if you see nested loop, just know that there was a dependent and a table that was stuck. Then in the table there was a dependent table, and there was a table that was sort of the parent, that child table. So in terms of the hash join, right? So basically what happens is that you have basically just have a you basically just have in memory creation for the smaller data table. So basically here, if you have, again, I'm working with a region and countries table, right? So here you would have an table creating a memory for this table for the regions table. um, and basically what this means is that this is going to be the in-memory table is going to match the raw data that it has with the larger data sets from the other table object. So again, table object is interchangeable with row sources and or tables. So basically, if you when you have the results that would be based, the results that for your data will be based on basically on that memory, that smaller data set that's inside of the memory table, and how well it matches with basically the large data set that's part of the independent table. So that's just the high strong concept. It's not very complicated. And then you also have a merge join. This is a very is it's very used. Again, you do have merge operations that you use. And typically, you're not coming across this join, but if you do, you just, again, I don't have more details on how it works. But if you do come across it, just do a little bit of research. It shouldn't be, again, it's just a join. It shouldn't be, rocket science or anything. So just figure out, exactly what's involved. And what you're doing is you're just working with two tables. And then so that's actually the short demo that I was gonna go over. I'm gonna now show you a diagram. So this is what I was trying to in terms of basically just dealing with multiple table objects, right, or row sources. So basically, if you have an index, right, if you have an index, and what it's doing is the index is reading the table blocks, and this is a join operation, right. So basically, you're gonna have an index, just do reading of these two table objects, right? So the index is, again, going back to what I was telling you earlier. So it's the preferred way to do this is to just basically just have the index read, um, you know, more rows as opposed more rows and less blocks for a more efficient approach. So basically, this is just what you be encountering when if you have an index and you have multiple table blocks. Uh, and in terms of just the index, let me see what I'm trying to say here. Again, what you can also do again just is basically just you can also create an index organized table. But again, with dealing with indexes, you just have to remember that if you want to make the work with index efficient and more streamlined, then it's going to require some memory. So again, going back to to using index organized table. So but otherwise, this is the activity. This is what will be. These are the activities that will be going on internally. With the index and table objects, you will have these different readings. Going back and forth, and then so this is how overall, you'll be able to have a firm result set, and then actual statistics that the optimizer will be able to pass through to reach to basically just perform and to come up with an efficient execution plan and basically in a slow response time for your query. So this is just a diagram of an index, just basically just with multiple objects, and basically again it's just the different readings, the different activities that are taking place, within the Oracle software. So now I'm going to focus more on cache memory, right? So all along you've been wondering, you might be wondering, oh, you know what? So let me just cache everything. So remember earlier I also advised you not to do that, because the more you cache, the less the lower. So again, you have a finite number of blocks, right, inside Oracle software. So basically that means that if you are caching a whole lot of like so many of those blocks in memory, then that means that you're not gonna have as many blocks that are available for read and write operations, right? So basically you would have again, so the optimizer cannot read a cache data. All the optimizer does is you're caching information to sort of have a pretty fine set of statistics that the optimizer can rely on. But then again, if that's the whole point of you having a cache data, then basically you just there's an avalanche of things that could go wrong. So I'm going to cover them in just a couple of just right now. So basically, again, so just going back to the concept of just the reads that are taking place inside Oracle software. Like basically, most of the reads are presumed to be, like IO reads are just presumed to be just physical reads. Again, I did this, at this level. Again, these are the performing milliseconds. You want to be on the lookout and make sure that this is not going beyond your particular thresholds. So what you can also do is you can just give directives for the optimizer to deal with cache data for the execution plans, right? So basically, so if you so the reason why you have cache data, right, is because you have you have these objects that are popular, right? These objects that are hot, these objects that are hot. And so basically, you just figure that so if all these users are constantly accessing these objects, right? So it would only make sense for me to basically just cache that into memory, and then so they can that would be sort of a more more streamlined approach. But basically, again, so if you want to have the optimizer just base all of its execution plans on that cache memory, that's not That's not always going to be the case because again, so what I have here, the reason why I have here is that some objects cache within memories and some do not, right? So if you okay, so again, so in terms of caching data into memory, it's not there's no one there's like like it's recommended to not cache certain types. Like if you have a large a table with a large number of rows, you definitely don't want to cache that, right? Because even though it's gonna be it's a table that's accessed frequently, you definitely want to cache that. So basically, what I'm trying to say is that there's an appropriate number of rows inside of a table object that at which point you should just consider caching that information. But in caching the row data details, basically what you're doing is you're taking away from other blocks, and then you might again the word that Tim that I used earlier is contention. You might lead to some sort of contention with the different writer processing inside of Oracle software. Um, so you can cache, but you have to cache the right object, and not all objects can be cached. Those are the basic points for what I'm trying to say. And you can actually just directly optimize it to again just figure out which execution plan works best based on the statistics that I gathered for the right type of cache raw data. So in terms of the optimizer, basically just index caching, right? Hold on, let me make sure I just say. Okay, I think these are just features. Yeah, these are just features inside of Oracle software that you can refer to for for reference points and then with the optimizer. So again, index caching is basically you can cache your indexes. That's very obvious, right? If you don't, you can do that as well as just cache the typical table the raw data for the table block for the table the typical raw data that's inside the block for the table object. Okay, and then you have again you have also this feature called optimizer index cost adjustment. So that's another feature that helps you sort of figure out again when I say cost, I'm mostly referring to just like what level of coin will be down. So again, remember cost it deals with first rows, and then you have different thresholds, right? So you have 110, 100, and 1000. So you can just figure out which what level you wanna you wanna have this adjustment set for the optimizer dealing with your index. And this is some statistics just of what method are you using for to gather to assess the data and and come up with the statistics for that data for those data sets. So you also have just a number of undocumented parameters, right, inside Oracle software. So the thing about the optimizer is that it's actually a work in progress still. Basically, what I'm trying to say is that Oracle has done a lot to streamline how it's being used, but like you find these some parameters inside Oracle software, and you just wonder to yourself, what are they doing here, right? But basically, the truth is like they're there because it's a work in progress. So eventually, basically the Oracle will be able to basically just put some add some meat onto this bone per se, and basically just make these more user friendly and more coherent for everyday use, and just tune in for your optimizer. So these are just some of the parameters that you would find inside of Oracle software. With optimizer tuning, you can spend some time to just figure out how these affect the operation side of Oracle software. And again, so basically just don't expect too much from these, but just be mindful that again Oracle is constantly just developing, like making this more just bring about more clarity to how you can effectively tune your optimizer with these, as well as new parameters that could be released with new Oracle software releases. And then also this is a very big point. This is a very important point here. So the caching will not always work, right? Which are for the optimizers. So again, just going back to what I was saying earlier. So again, these are just some of the things that you're bound to experience if you sort of rely on caching, right? You're gonna have CPU starvation. So think about it this way, right? You have a finite number of CPUs inside. You have a finite number of CPUs, and you also have a finite number of blocks. So those two things are eventually going to give in to just not being able to service other user requests, right? So by servicing user requests, what I'm saying is that, okay, if you have, let's say you have 50 again, this is highly hypothetical, right? So if you have 50 blocks, right, and you have about 30 of them cache in memory, that means that you have 20 left for just daily operation, right? And let's say you have an overwhelming number of DML operations being submitted, inserts, updates all over the place, right? What that means that you only have 20 blocks where those operations can be written to and can be then transferred into the final storage area, right? So that's not really efficient, right? What you want to do is even though you want to have a cache, their cache in memory, like you don't want to just do it for the sake of hey, I'm going to streamline these operations to the point that I don't have to worry about that. That's not going to happen. Just this is going to be very dynamic. You would have to make a lot of modification to this. And basically just and again this is what you're bound to encounter. You're gonna again you need to have the more blocks you have, the better it is for your for level of activities that go inside of the database. And again again this is very simple, and the more blocks that you're eating up with your cache memory, the less that number of blocks will be. So just be mindful of that in setting up your cache your cache data for in dealing with the optimizer readings. And also you're gonna have CPU starvation, right? So if again these two things are finite. So with a CPU you might have hey, you might have a 4 CPU, whatever number CPU is. But basically what I'm trying to say is that you have CPUs that are dedicated to servicing your cache memory, right? And that means that let's say you have 4 CPUs that are inside the system. So, and you have 2 CPUs that are dedicated to servicing your the cache memory. So that means that you only have 2 CPUs left for all the other operations, right? Which is very I would say not efficient, to put it mildly. So you want to be able to just allow for this, just give access, just give latitude to the CPUs or the number of blocks. Just allow for some sort of free flow to the to the read and write operation that goes inside the open software, and don't try to just basically just have those resources just be associated with a particular type of operation, at this time being the caching operation. So just be mindful of those two side effects of caching your data into memory. And also on a closing note, so basically just be mindful of this, right? So in terms of the optimizer, so this is a term you're bound to encounter. Again, cardinality, right? So if you have a cost-based approach, when I say cardinality, what I'm referring to is basically with cost based, you have a choice of first rows, and you can also choose all, right? And so if you have first rows and you have a number of rows that you're retrieving, right, that are representative of the overall data set, then that means that basically again that's what the optimizer will base is this is just that is processing. Okay, so if you have 20 rows, the statistics will be based on those 20 rows that you're retrieving. And again, you have to be mindful of what exactly the optimizer will be looking for, and what's actually there. So So basically, again, Carnati, you want to be, you want to just, have the right number of rows that's being sampled. But basically, just remember that, the optimizer is not really looking at the Carnati, it's looking at representative data. No, no, not. It's looking at statistics that has to deal with either representative data or just entire data sets. So just remember that basically whatever levels the Carnot that you're setting, you might want to just set first row Carnot, first row to 100 to get as many rows as possible. And again, that might not be reflective of the overall data set. So just consider those factors in dealing in setting up your in sort of having perfect configuration for the optimizer to see through. So that's it. Okay. Consider those factors in having in just accruing the right statistics for the optimizer to see through. That's what I'm trying to say. So again, Carnati, you can set that with this is mainly referring to I'm mainly referring here to the cost space and the number of rows that you can use that you can play to get a sense of what's going on with your raw data. And also internally you have clustering, right? So clustering basically the clustering basically it ties in with if you have a single object or if you're performing also a joint operation. But basically what you have to be mindful of here is that clustering, like this is not that is not always going to be clustering. You're not always going to have organized tables for your cluster data. You're not always going to have index organized tables for your for your indexes, right? So and then data is not always going to store in indexes. So again, there are different aspects of clustering. So again, so just be mindful of those different aspects of clustering, and just remember that if you want to just maximize a particular feature, let's say the index organized table feature inside for your index, basically that's gonna require more memory. So just be mindful of those those dominoes effect in setting up your configuring your clustering clustering inside of your Orca database. And you can also provide directives to the optimizer as I've just gone over by basically just again just putting some particular hints inside of the select statement. Um, yeah. So yeah, remember I showed you the forward slash with the star and the plus. And then that's typically what you enclose your hint with. And also you have caching, right? And then caching is very useful, but again, this is just a piece of advice on just using in moderation, right? So it can have a negative effect on the optimal performance. Again, so the more memory you cache in, the more raw data you cache into memory. Basically, you just tell the optimizer basically, hey, just focus on these statistics that I've gathered for this cache memory. So you're not really accounting for things that are unexpected. So again, think about it this way. Dealing with databases, you can't, that's the one place where you can't have where you shouldn't just think of, I'm just gonna have this setup, this configuration is gonna work all the time. There's never gonna be a 100% of the time with dealing with databases. There's fluidity with in dealing with them, because you have different the data is constantly changing, and the operations are constantly different operations constantly being performed. So just be mindful of that in dealing with caching. So, and in terms of just using index clusters, hash clusters, and again just in an index organized table. So basically what I'm trying to say is that using these this is an option that you have, right? So if by default what you're gonna have is you're gonna have a heap organized table that's just being performed. That's the default method for local software, right? But if you want to go beyond that default method, you can use the index organized table to just have a better reference point, with more clarity, right? But then again, what you'd be doing is, it's all about the memory and the resources that you're using up. Like you can do so much, to make sure to ensure that the optimizer is just working at the most optimal performance, right? But again, it's going to require a lot of memory, and then so you have to weigh, the memory, with the optimizer's expected level of operation, as well as what would be what would make sense as a as a for your environment. So just always remember that it's not just making the your environment very too lax is not it's not always going to be a good thing, because again, you got to be able to, like, make modifications to your environment to get to maximize the efficiency, and again to lower the cost, for just for in to lower the cost, both for your employer, or for your client. So just again, you just gotta you can't have a configuration and think it's gonna solve all of your problems. That's not gonna happen, or it shouldn't happen. Um, and also, what I was saying earlier, basically, just optimizer is not aware of anything that's going on. I mean, not anything, but like the things that you would consider, you would think the optimizer is actually reading. It's not. If you look at the expressions, the decode between the optimizer is not reading those. What it does is it only looks at the statistics, right? So the more clarity you have to the statistics, the better your execution plans are gonna be. So basically, again, that's why I started out with which method to use. And then so now, the approved method is the cost based method. For for tuning for the optimizer, the optimizer activities. Again, the reason why eventually everyone just settled on using cost based is because, again, it's you can basically just have more control of your statistics, right? To have the right, or to have an effective execution plans laid out. So really, so anytime you hear someone tells you, okay, my query is taking really long time, can you help me resolve this issue? Just always just review what the execution plan says, because if the execution plan is jacked up, then that means that the response time is definitely going to be jacked up as well. So just make sure to always review the execution plan. If you again, just be mindful of the optimizers. If you have an index on a table object, and basically you're expecting the optimizer to do an index range scan, but basically it ends up doing something else. But that could be because the table object is too small, and basically performing a full table scan is actually more efficient than doing a range scan reading. So just be mindful of how the optimizer might have a mind of its own in doing this, but just always review the execution plan to figure out what's going on with optimizer. And then these are just some of the features that you have inside of Oracle software. As again, so the optimizer, in doing the optimizer, this is a developing feature. So basically, what Oracle has been doing lately is been implementing like different different functionalities, right? So you have adaptive cursor sharing inside of Oracle software, and basically what it does is it basically just allow this local server to measure how effective the bound variables are for the execution plans. Again, it's all about streamlining not streamline, but just what type of information is being presented to optimizer that goes into the execution plan, and just laying out the execution plan. So Uh, Again, this is just a one method that Oracle went about to just just measure how effective those bound variables are. Um, and also, you have another feature called a cardinality feedback. Basically, what this does is just again, it's just it looks particularly at the execution plans, and basically it actually just helps the optimizer when the optimizer cannot figure out what number of rows are part of the part of basically within inside the object, right? So basically what it does is it tries to again, so if the optimizer has a particular number of rows in mind, then what the cardinality feedback is going to do is gonna nudge it forward in terms of basically just figuring out exactly what that number of rows are. So I think I actually ran a query earlier. If I'm able to pull it up again, it actually showed a cardinality feedback. I'm not sure if I'll be able to put up now, but basically, it's gonna show up at the yeah, I can't like I've run too many calls, so it's gonna show up on your after you execute your execution, your execution inquiry. Your core to review the execution plan is gonna be it's gonna say basically cognitive feedback has been it's gonna definitely mention that cognitive feedback was used. But again, just remember the reason why cognitive feedback is used is because the optimizer is not able to cannot it's not able to basically just deduce the number of rows the that are inside that table. So okay, this is it. Just thank you so much for watching. I hope to see you guys next time.